Okay, we're off and running. Here's a bit of review work for sections 1.7, 1.8, and 2.1 in the textbook. This material was covered in quiz 3. So for those of you who need to do retakes, now's the time to pay attention. So let's say that we have a parabola that goes through that point and that point like that. So we'll say, okay, we can see roots right there. What are the coordinates here? They are 1, 2, 3, 4, 4, 0, and -2, 0. And so we can say that a factor, if a root is 4, then the factor will be x minus 4. Notice I have to change the sign. And another one would be x plus 2. Again, changing the sign. So we'll say f of x equals some value of a times x plus 2 times x minus 4. And then we have to think to ourselves, how can we find what the value of a is? Well, in order to do that, we would need to know some other point that this graph goes through. And in this case, we can pick one right there pretty nicely. And that is, let's see, where is that? That is 3, -2. And that alone can help us figure this out. So we can say -2 equals, there's our value of a, times, what's x then? 3 plus 2 times 3 minus 4. So again, notice my 3 is an x value. 3 goes here. My -2 is a y value, so -2 here, f of x. And the only thing I'm missing now is a. So we can solve for a and then write this in more general terms. So I can say -2 equals a times 5 times 3 minus 4. Watch your sign. It is -1. So now I can say -2 equals a times -5. And we would want to solve for that. So I can say -2 over -5 equals a, dividing both sides by -5. So then I can say positive 2/5 equals a. And I can write an equation for our parabola way up here, a equals 2/5. I'm going to remember that. So now I can say that this parabola is f of x equals 2/5 times x plus 2 times x minus 4. Or if you're graphing it, you could say y equals, but I like the equation itself. F of x equals 2/5. Let's write it out as a trinomial. Factoring or multiplying that out, x minus 4, x plus 2, x squared minus 4x plus 2x minus 8. So that would give us 2/5. We have to multiply that and distribute it later, times x squared minus 2x minus 8. Notice I took the negative 4x up here and the positive 2x up here and put them together, and I got minus 2x minus 8. And if you'd rather do it FOIL style, the old school FOIL, you can go x times x is x squared. That works. Then you can go x times negative 4 is negative 4x. That's what we had up here. And then you can go x times 2 is positive 2x. And then you can go 2 times negative 4 is negative 8. So it works there too. All right, I'm going to get rid of that. Now we should finish this off by distributing, and we can say f of x equals 2/5 x minus 4, oh, x squared, I lost it. Glad you caught me there. Minus 4/5 x minus 16/5. That little 5 kind of got lost down there. I'm going to fix it. Beautiful, beautiful, beautiful. And then, as always, let's graph that just to check and make sure it looks kind of like that. Okay. So I'm going to put that there. I'm going to bring in my calculator. And let's see what that looks like. So y equals, oh, I guess I should turn it on first. Turn it on first. So then I am going to, I don't need this one here. I'm going to turn this one off. Enter. Notice the equal sign is no longer illuminated, so that one's off. So then I'll just go right here on y sub 4 and put equals plenty of, maybe I can move it over here and make the whole thing work. Plenty of parentheses, 2 divided by 5 x squared minus 4 divided by 5, 4/5, x minus 16 divided by 5. Now I don't need all these parentheses, but they sure don't hurt, and many times they help. Then I'm going to go zoom 6 for standard. And there is my parabola. It crosses with a root at -2 at +4. And I'm not sure about down there, so to see that, I'm going to look at my table. Oh, I don't like the table the way it is, so I'm going to go second table set. Start at 0. Delta table, or change table, by 1. Now that should be a little nicer. So let's see. We had -2, 0, there's a root. We had 4, 0, there's another root. And remember, we had 3, -2, I believe, was a point on there. Let me go up a little bit. Yes, 3, -2. There it is. So our graph is good. Our equation is good. And we can say, yes, that's a keeper. Okay. Now, pause this if you need to study it or back it up. So that'll help. All right. Let's do one more problem, kind of different a little bit. So let's say all right, let's try another one. Let's say let f of x equal 2x cubed minus 18x over x minus 3. Number 1. Tell whether f is a polynomial function. Because right now it certainly doesn't look like it. It's kind of in disguise. Number 2, give each value of x for which f is undefined. Values of x where the function f is undefined. Well, that one, undefined. That one looks a little bit easier. We can handle that. 3. And then give the zeros of f, or roots. So let's tackle this. Okay, so is it a polynomial function? So, no, it is not. The reason being is that because it's a quotient, a division problem, and a quotient of 2 polynomials. And we can't have that. Won't work. So values of x where f is undefined. Well, the first one that jumps out is anywhere where the whole thing, the whole denominator, the bottom of the fraction, would be equal to 0. So the first place we would look is where x minus 3 equals 0. Because then the numerator isn't really going to matter. So if we just look at where x minus 3 equals 0, we'll know one place where it's undefined. So x would have to equal 3. So now we're ready to give the zeros of f. Well, just looking at this, it's not very easy to deal with right now, but I see that there's an x here and an x here, and that helps. So let's start to give this a little bit of a makeover. So we could say f of x equals, and in fact, more than just an x, now that I look at this closer, I see there's a 2x here, and 18 is an even number, so we can factor 2x out, not just x. So let's factor 2x out. That would leave me x squared minus 9. Oh, and then that gives me some ideas already, just seeing that. Divided by x minus 3. I put that in parentheses maybe to help us see in a minute. So when I see x squared minus 9, remember, little bells go off in my head when I see things like x squared minus 4, or x squared minus 9, or x squared minus 16, or x squared minus, you guessed it, 25, etc. Those are perfect squares. So now I think that I can write this even better as 2x times x plus 3 times x minus 3. And you may be looking at me like, okay, where did you get that? Where did you pull that out? But if you practice with any of these perfect squares over here, you'll see that they come out as being one positive, one negative, only 2 terms, and it comes out very, very nicely. You might want to practice with some of these. They're not part of this particular problem. Okay, so now we can say that these will divide out, but we don't want to forget what we did up here, that it's undefined where x equals positive 3. That's where that one's going to come from. There's probably going to be some type of an asymptote there, vertical asymptote more specifically. So we don't want to lose that. But at the same time, it makes our life a lot simpler. F of x equals 2x times x plus 3. Now, we're going to say that there's a root. A root occurs where it's going to cross the x-axis. And what is the y value? The y value, in other words, 5, 4, 3, 2, 1. What is the y value right there where it crosses the x-axis? It is 0. You're right. So now we can say 0 equals 2x times x plus 3. And at that point, where it crosses the x-axis, we'll get a root and be able to answer this question. So we know that when one item is multiplied against another item, and the resultant product is 0, that either 2x equals 0 or x plus 3 equals 0. It has to be. Has to be, has to be. Think of it like something times something else equals 0. Well, one of these somethings has to equal 0. So then we can say 0 equals 2x or 0 equals x plus 3. And that means 0 equals x when you just divide both sides by 2, like that. Still 0. Or subtract 3 from both sides, and you get 0. Not 0. What am I saying? Negative 3. Sorry. Negative 3 equals x. Okay? And these are our roots. Okay, so let's see. We answered number 3. Give the zeros of f, or the roots. Place where f is undefined. X equals negative 3. We suspect there's going to be some kind of a vertical asymptote there. X equals 3. And it is not a polynomial function because it is the quotient of one polynomial divided by another. All right. Lastly, let's graph this and just see what it looks like. I'd always like to graph things to check them. And we have time. We're not yet 20 minutes into this vodcast, so come on. See if I can get my calculator up here. Come on. It's being shy today. There it is. Okay. So originally we had, I clipped and then it went away. Let's just bring it up. Okay. I think we can make it work here. I'm going to bring it right here and then we can see it. So we have, oh, we don't need this one. So I'm going to turn this off. And I'm going to type this one in. And again, lots of parentheses. So we have 2x cubed. Make sure you bring this down in your calculator. The newer ones, you have to do one extra step, but it looks better. Minus 18x, close parentheses, divide, open parentheses, x minus 3. Okay, and we're good there. And we said we had roots at 0 and 3, so again, our zoom 6, our standard 1010 should work. And there we go. There's a root at 0 and a root at -1, -2, -3. And that's good. But wait, let's see if we can get an asymptote out of this deal at positive 3. I want to see what that one looks like. So that would be up higher. So we're going to have to change our window to, we don't need -10. I want to see like negative 4 should be fine. And then 10 might be good. And we don't need negative 10 down there. Negative 2 might be fine. And then x max, let's go up to 20 and see what that looks like. Should be something at negative 3. Maybe it's a hole there. Maybe just a hole. So I was wrong. 1, 2, 3. Let's look at our table. And maybe at negative 3, no, at positive 3. Ah, there it is. So it's a hole, not a vertical asymptote. I was wrong. I suspected that. But it is a hole at x equals 3. Interesting. So right there we get an error. Hard to see. On a really, really good calculator, you could probably zoom in 1, 2, 3 and see that hole, but we don't have that ability on here. But we know it's there because the algebra supported that. So that's cool. So that's all I have. Thank you for watching, and I hope this is helpful. Have a good day.